Okay, so when we're adding and subtracting complex numbers, it's a very simple process. We're going to combine like terms. We're going to put the real parts together. We're going to put the imaginary parts together. You can't get any easier than this. So I look at this problem. I know it's addition because I got two sets of complex numbers. I got two complex numbers in the parentheses, and I got a plus in between them. So we're just going to add the real parts, the 5 and the -2. That gives us what? 3. And then we add the imaginary parts. 3i plus -5i is -2i. Now, the standard form, remember, the standard form for a complex number is to put the real part first. It's not mandatory, but it is the standard way to do it. Okay, that was easy. Now we go over here. You got to be aware of sometimes where they may not be putting them in standard form. So you have to understand, don't get confused as to what part is the real part. Here, -6 is the real, and 8 is the real. So -6 plus 8 is what? 2. -5i plus -7i is -12i. Okay? So easy. Careful with your signs. Okay, let's go to another set of examples. Okay, here's several more. Just on your own, just real quick. Work these problems. Alright, so in number 1, we want to combine the real parts, 6 and 7. What does that give us?
13.
And then the imaginary parts, 8i plus -11i, -3i. And that's it. Alright, number 2. Jakaya, what'd you get for number 2? For the 4 for the real part, and then? That's right. Alright, number 3. Jared Seaver, what'd you get for the real part? Alright, what'd you get for the imaginary part? -18i. Good. Alright, and then number 4, Chris, what'd you get for the real part?
I got 15 plus 3i.
Alright, good. Guys, put the real parts together, put the imaginary parts together, and you're done.
That was a
Okay, so when we are subtracting, you have to be careful to change your signs, including the minus, everything after the minus. Okay, so in this one, the real parts give us 2, the imaginary parts give us -5i. In the second one, -11 plus 6 is -5. 4i plus -3i is 1i, or just I. Any questions? No, I'm not going to be drawing any flowers. Okay, so again, it's a good idea to go through and change all your signs. Plus, minus, plus. Plus, plus, plus. Plus, minus, plus. Alright, and then notice this last one, the minus, wherever the parentheses is, if there's a minus in front of it, change all the signs. Okay? So we've got 2 minus I. You can say minus 1i if you want to, but it's not necessary. Alright, we've got -3 plus 18i. We've got 7 minus 4i. We've got 16 plus 8, which is 24, plus 3i. Combine your imaginary parts and your real parts. Real parts, imaginary parts. Okay? So this stuff is super easy. So when we multiply complex numbers, we're using all the properties of multiplication that we've used in the past. All right? the distributive property for 1. All right. Sometimes we may have to FOIL, which is just multiple distributions. So when we do that, when we get to our final answer, we want to make sure we put it in standard complex number form. Okay? So in this problem, we're going to distribute the 5. That's going to give us 30 minus 10i.
Okay, so like, whenever I was asking you what I was asking,
Yes.
I was asking you, it was supposed to be like writing out like a 5 or something, and then it was just going to bring us back to the previous state. So, yeah.
Okay? In this next problem, when we distribute, now you can, if you're good, an astute math student, that means you notice things. All right? You notice that these are the real, this is the real part right here, correct? So when I do this, I might go ahead and do that first. Negative 2 times negative 4 is positive 8. Negative 2 times 3i is negative 6i. Same, okay, over here it's just negative 24 plus 16i. Easy, easy. All right, let's do the next part. Okay, now we're distributing an imaginary number onto the parentheses. So do these problems.
To use that I squared thing and put it back like,
Alright, so 3i times 2 minus 4i. So we're distributing just like we did before, but look, be careful. Notice things. 3i times 2 is 6i. Make sure you keep that I with it. But when I multiply 3i times negative 4i, I get negative 12i squared. That can be simplified. Negative 3 is positive 3, negative 4 is negative 12. I times I is I squared. But what is I squared?
you took out negative 1.
It's negative 1. So this is actually going to be 12 plus 6i.
Plus 6i. Plus
Yep.
6i.
So make sure you put the real part first, Cassie. Alright?
Hold on. Coach, you gonna work out? Yeah, it's gonna work out like that every time, ain't it?
If there's an I squared, yes.
That's why I thought it would be a negative.
Alright, and you will often see I squared. Alright, so 4i times negative 3, negative 12i. 4i times 2i, 8i squared. But what does that I squared do? So every time you see an I squared, cancel it out and change the sign of the number that's with it. It's that simple. So this becomes negative 8 minus 12i.
What is that?
Okay? So that's pretty simple as long as you remember to change the sign. Okay, now here we have some FOIL problems. Go ahead and copy these down and use the FOIL method to do these. Distributive property, we see that 3 times 4 is 12. 3 times negative 3i is negative 9i. 2i times 4 is 8i. 2i times negative 3 is negative 6i squared. Okay, so first thing I would do is go ahead and get rid of that I squared and make that a plus 6. There's no more I with that. So now 12 plus 6 is 18. Those are gone. Negative 8, 9i plus 8i is negative I. So that's the answer. Alright, same thing over here. 24 minus 28i minus 30i. That's ugly. Minus 30i plus 35i squared. Okay, the I squareds are going to cancel. I squared is going to cancel. Make that a negative. So 24 minus 35 is negative 11. Those are gone. Minus 58i. Remember, don't make it I squared because you just combine them through addition. Okay, guys, y'all need to work on these on your own from the video. dividing complex numbers. In order for us to divide complex numbers, or in short, to simplify complex expressions where there is an I in the denominator, we're going to have to use what we call complex conjugates. These are two complex numbers of the form a plus bi and a minus bi. So, a plus bi and a minus bi are complex conjugates. They're not opposites, but they're almost opposites. What they do is they cancel out the i's. Okay? They cancel out i's. Now, look. I've got a 3i in the denominator here, and I've got a negative 2i over here. I don't want i's in the denominator. So what I'm going to do is I'm going to multiply the top and bottom of this fraction by 1 in the form of complex conjugate. Here's how we're going to do it. 3 minus 2i over 3i times the complex conjugate of 3i. What is that? Negative 3i. Why is that? Because what is my a value in this problem? It's 0. So a plus 3i is the conjugate of a minus 3i. Or 0 plus 3i is the conjugate of 0 minus 3i. So I'm going to multiply the top and the bottom by negative 3i, which is the conjugate. Do I need the 0? Do I need the 0 right here? No. Now, when I do this, look what happens in the denominator. 3i times negative 3i is what? Negative 9i squared. Leave the I squared for just a second. Alright, in the numerator I have to distribute because this is one thing. Negative 3i times positive 3 is negative 3i. Negative 3i times negative 2i. Distributing.
That's not negative 9.
Oh, I didn't write 9, did I?
Point.
Okay, that's fine.
1.
Negative 3i times negative 2i is positive 6i squared. Okay, now we can simplify. So, go ahead and mark out your I squareds and change your signs. I squared go away, make that a negative 6. I squared goes away, make that a positive 9. So now, put it in standard form. I want my negative 6 first. Minus 9i over 9. Now, is there an I in the denominator anymore? Nope. Because of complex conjugates, we were able to get rid of that I in the denominator. Now, all I did was multiply by 1. You say, how did you multiply by 1? Because the number over itself is 1. Okay? Now, is this in simplest form?
No.
Why not?
Because they got it already.
Because of what? They're all divisible by what?
3.
3. Good.
I thought that you couldn't do nothing to it because the top is all together.
No, I can divide every part of it by 3 as long as I do every part. No, they won't cancel out all the way, but they're all divisible by 3. So, negative 6 divided by 3 is negative 2.
Minus 3i.
Negative 2, negative 3.
And then
All over 3.
Now it's in simplest form.
when will we do that thing where she told us
Okay.
that song?
Now y'all do the next one.
You talking about the
Okay, so we're going to multiply top and bottom by the conjugate, complex conjugate, which is 2i. So understand that part goes in parentheses. Alright, so we're going to get on top 10i plus 6i squared over negative 4i squared. Now you go through and change your signs. So we are left with on top minus 6 plus 10i over 4. And I can simplify that. Is that what you have? Alright, so we're going to divide all these by 2, right? So, negative 3 plus 5i all over 2. Okay? Now, I'm going to give you a little bit of homework
We simplified it by 2.
over the long weekend. However,